Okay, I've got another exam walkthrough. This is October 2023, Unit 2, question number 14. So I want you to pause the video, do the question yourself. You should do this with all the exam walkthroughs. Just pause the video and do the questions. I might not say this in every video, but you should pause the video and do the question yourself, and then I will solve it. So just pause this video. There's a big 6 marker here as well, and it's not that hard actually. So just do try it, and then I'll do the question. Okay, so looking at this question, just having a glance on it, I can easily tell this is a potential divider circuit. Okay, it always looks like this. We have two things in series, and then we have the circuit supplying potential difference to some other component in this way. And then we have a thermistor here as well. Now, something unique about the thermistor is as the temperature increases, the number of conduction electrons increases, so its resistance is going to decrease. Okay, and we can see that graph here as well, that the resistance, as the temperature is increasing, the resistance is decreasing. Notice, right? Okay, so the question tells us that we have a temperature sensing circuit that consists of a fixed resistor and a thermistor as shown. Okay, and then it says the circuit supplies a potential difference to operate the heater switch. Okay, and then the heater switch will turn on when the potential difference across the thermistor is greater than 0.7 volts. Okay, and then they tell us, so this is a very important point, it's going to help us out in this question later on. The PD across the thermistor should be greater than 0.7 volts. And then they've given us this very common graph that we usually get in exams of resistance against temperature. And they've given the resistance in ohms. Sometimes they're given kilo ohms as well. Okay, and then they tell us, deduce whether this circuit would switch on the heater when the temperature falls below 10 degrees Celsius. Now, first thing I want to write is that as temperature decreases, so it goes below 10, like 9, 8, 7, it goes lower and lower and lower. As the temperature decreases, the resistance of thermistor will increase. So that's a point I'm going to write, and I'm going to refer to that in a bit. Right? Now, first thing I want to do is I want to calculate the resistance of the thermistor, and they have given me a hint here as well. You should include the calculation of the PD across thermistor when the temperature is 10 degrees Celsius. So 10 degree would be right over here, and that's going to be 2 ohms. So let's say the temperature is 10 degrees Celsius and the thermistor's resistance is 2 ohms. So I'm going to write at 10 degrees Celsius, the resistance of thermistor is 2 ohms. So I can use the formula V total is equals to IR total. And then I can find the value of I. And I'm going to get I as 0.353 amps. And then I can find the PD across thermistor. Thermistor is going to be equals to IR. So 0.353 times 2. So I'm going to get my answer as 0.705 volts, which is almost actually 0.7 volts. Now, I referred to something above, and that was as the temperature decreases below 10 degrees Celsius, the resistance will increase further. Okay, let's write that here as well. And then you can say that the PD across the thermistor will increase as temperature goes below 10 degrees Celsius. You can write that down as temperature goes below 10 degrees Celsius. So the PD will be greater than 0.7 volts and heater will work as needed. Okay. I would have preferred to write this point down here actually. I think I wrote it too quick. You get 4 marks for this and you get 2 marks for this. So here it says why the resistance of the thermistor changes with temperature. So this is the answer. As the temperature increases, the number of conduction electrons increase, or you can also say that electrons move into the conduction band as well. So that's going to give you 1 mark, and then you can write that due to this the resistance decreases. That's going to give you the 2nd mark. Okay, so that is the question. I will show you the mark scheme and the examiner report.